Alright, so today we're going to look at series and parallel circuits. These are the two ways which you'll most commonly see circuits set up as. First we're going to refer to circuit A and circuit B. This is what it would look like in general, but this is the diagram. And you actually see why we use the diagram. It would be much easier to work out how to set this one up here in particular from this diagram here than it will just there. Alright, so series and parallel. Basically, circuits can be either series, which is circuit A, or parallel. A really easy way to remember is you've got it all is connected together in one long series. Or here, you've got one circuit here and another circuit running parallel next to it. Series circuits, there's only one way that charge can go around. There's only one path for the flow of current. However, when we have a parallel circuit like we do with B, there are alternative paths for the current to take. So the best way to summarize the differences, aside from those two, that's it, aside from doing it experimentally, is with the Venn diagram. So once again, we're back to A is the series and B is the parallel. So we've got a series circuit. Over here, you've got one pathway, whereas with two or more pathways. The similarity is that it will still convert energy to light, heat, sound, whatever you need it to do. It'll still work as a circuit. The current in a series circuit is the same everywhere. So if you put an ammeter there and an ammeter there, it would be the same. Whereas if you put an ammeter here and an ammeter there and an ammeter there, it would be different because the current in a parallel circuit splits. The voltage shared in ratio to resistance. Now, what this means is if you put a voltmeter here and another voltmeter here, what you would get if these two lamps or light bulbs are exactly the same, you would get the same voltage, and it would be an even split. If you put a voltmeter here, you would actually get, so just say the total volt here was, we'll say 2, just for the sake of it. This would read as 1, no, that would read as 2, whereas here you would have 1 and 1. The voltage would be split evenly. Whereas what happens here, if you've got a voltmeter here, and one here. The reason you have it around here is it measures the total circuit, so actually that one that says 2 would be better off being here. Ignore that. That would say 2 there. So you've got that there. That would say 2, but here it would say 2, and it would say 2 as well. The current is split in this one here, but the voltage, the energy that the current carries, isn't. Over here, the current is not split, but the voltage, the energy, is shared up by both of the loads. The total resistance is, that doesn't matter to us at the moment. So if this bulb breaks, just say you take that bulb out, the circuit is dead. It is no more. If you take this circuit out, this one will still work. There is still a circuit complete. There's a complete circuit. So if we lose a light bulb, like you used to in the old style Christmas lights, it was all gone. If you lose a light bulb you're doing modern style Christmas lights where they're all in parallel, the rest of them will still work. Now, with these ones here, because they are sharing the voltage, the light bulbs will be dimmer. Whereas these two, they both have equal amount of, they both got the full voltage of the circuit, the voltage will be higher. But these ideas are best explored in experiments. So you should make sure you get this down here, and this is something that your teacher will go through in class in an experiment. Alright, if there are any suggestions, any questions, write them in the comments below, and we'll get to you as soon as we can. Thank you for watching, and see you next time.